In this problem, this is a little bit of a tickler, an unusual problem. Your velocity changes from 50 meters per second to the left to 10 meters per second to the right in 15 seconds. What was your average acceleration? Be very careful when we're solving this problem. And we're going to use a systematic approach just like we talked about before. When we start off with some speed, 50 meters per second to the left is going to be negative. So let's draw that Cartesian line again. This is negative and this is positive. So if I'm moving to the left, my velocity would be negative. If I'm moving to the right, my velocity is positive. So this second one is to the right. 10 meters per second to the right is positive. So I'm going to write down some things. V naught and V, or we'll call that VF. Sometimes we'll write it with an F or sometimes no. The initial speed is what we start off with. That's negative 50 meters per second. The final speed is what we end up with. That's positive 10 meters per second. And if we ask most people who are on the street as to what the velocity change in this case is, they're going to miss it. They're not going to get it right. They're going to say the velocity change is simply the final minus the initial. So they'll say 10 minus 50, ooh, 40. Uh-oh, not true. Let's draw another number line. And this is this speed, a number line. And this is negative V, and over here is positive V. In the center, we'll draw a 0, and that is 0 meters per second. That means the object's resting there. Let's draw the initial speed. The initial speed is, negative 50. It's going to be over here in negative territory. So I'll call that negative 50, meters per second. And over here in positive territory, we'll be at positive 10 meters per second. Let's label. V naught is 50 and VF is 10. Remember, the delta V is the final minus the initial, or we may draw it as V minus V naught. So let's apply. These equations are the same. The final speed is positive 10 meters per second minus the initial speed is, that's unusual, negative 50 meters per second. And to find the delta V, we say positive 10 minus negative, minus the minus is a plus, so that becomes positive 10 plus 50. The velocity change is positive 60 meters per second. So again, that's the delta V. Very unusual. Now let's discuss this back on the number line. We start off with a speed here, and we end up with a speed over there. So the delta V, it's in the positive direction. So we end up with a positive delta V. Now if we want to convert this delta V to an acceleration, we need only to divide it by time. So the delta V, which is 60, divided by the time that it takes is, let's see here, 15 seconds. And interesting enough, we end up with a acceleration of positive 4 meters per second. That velocity change is a lot more than we predict. Very tricky. Pay attention, stay organized, and you will not miss these problems.